Hello and welcome to this webinar hosted by Element 14 in collaboration with Low Power Radio Solutions. Today we're going to be talking about designing for the Internet of Things, balancing cost, features, and security. And presenting this interesting topic is Rick Winscott. If you have any questions for Rick during the course of the webinar, please put them into the Q&A window and I'll make sure to ask them at the end. And without further ado, I hand you over to Rick Winscott. Take it away.
Great. Thank you very much. So to start, I would say we need a little bit of definition, perhaps maybe a description of what the Internet of Things are, what they do. We have all kinds of objects around us. They aren't smart, they don't talk with each other, and they certainly don't talk to the Internet. And this is really kind of the central idea behind the Internet of Things, getting those objects to talk with each other, communicating with Internet services, and helping us make smart decisions. People often refer to them as the cloud of things as well. So what kind of objects? Let's take this object as an example, as a thermostat. And if we take a microcontroller and we put that microcontroller inside the thermostat, we get something like this, the Nest thermostat. It can program itself. It can create personalized, schedule-based temperature changes based off of the input that it receives or environmental events. It senses when no one is home and can automatically adjust the temperature accordingly. And you can even make adjustments remotely as well. All this to save energy on your heating and cooling bill. It's quite amazing stuff. Now, Gartner says that we're going to see exponential growth in the IoT over the next 2 years. 26 billion units worth of growth. And that's a fair quantity of smart internet-connected devices, pushing data here, pulling data there. Now this also sounds very exciting, but in this great green field of opportunity, we have a responsibility to do IoT right. And so this is a bit of a plug for being environmentally conscious. All those devices are going to need power of some kind. And managing power consumption is going to be very important if we want to have the IoT be a positive impact to us and to our future generations. This is a topic for another day, but it is definitely worth mentioning. So going on to the first part of this presentation, minimizing costs per node. What nodes are, what goes into them, what about the cost of making them, and how can we keep those costs manageable? To start then, what is a node? And we've already been talking about a node, the Nest thermostat. Now, in some cases, we would only have one of these in a home, perhaps two, but there are circumstances where we might have 2 or more, like the Nest smoke detector and CO2 detector. These nodes typically have very specific purposes, specific jobs that they do. Oftentimes people refer to embedded systems this way. This is a very specific purpose. This is not a general purpose computer inside of these. The design behind these is very, very specific. So in each one of those devices there are a whole bunch of parts. I mean, we're talking about resistors, capacitors, and some larger components as well. And the list of what we have to put together to build one of these nodes is called a bill of materials. Now, the resistors and capacitors, they aren't typically expensive, but we do need to keep in mind that the cost per node is impacted heavily by the quantity of the parts in your design. I should say unique components in the design. This is where things start to get exciting. We're experiencing the rubber meeting the road here. You've got your idea, and you've turned it into a spreadsheet of parts that you need to build your device, and going to the next step. As we've discussed, IoT devices, they need to communicate with each other and to the Internet. So let's take a look at the wireless option and how it might impact our bill of materials and our cost per node. So Internet connectivity means Wi-Fi, right? I mean, it seems pretty logical. It seems like the natural choice. And technically, it's easier to get nodes talking to each other and to the web if we do this. I mean, we're dealing with proxies, routers, switches, stateless protocols. All this requires a proper IP stack. So, but really the cost of Wi-Fi, setting it everywhere on every node, it's going to add up. and I'll give you an example here. And with the Texas Instruments CC3200 dev board, I need to say here that I have nothing against using Wi-Fi in an IoT project when it's clear that that's what needs to be used. The danger that I'm trying to point out is that component selection can have a snowball effect on cost. What might seem like a really good deal here is actually kind of a little bit more expensive in the end. So anyways, this dev board pictured here, this costs about $30 from your local parts supplier. That would be DigiKey, Mouser, Arrow, or Farnell Element 14. And TI is not making any money here. The purpose of this board is to get excited about the platform, and to the point that you're willing to put the CC3200 in those billions of IoT devices, right? So basing your estimates, your bill of materials, and cost per node on these dev boards, it's not a good idea. Excuse me. So to get a handle on kind of the reference implementation cost, I'll give you an example here from the just the IC here. In single quantities, you're looking at $14 or so, $15. And but there's going to be more components that you're going to need to get this working. So I'll deal with this on the next slide. But before I go on, I want to make one quick point here with the lead time here. This is a topic for another day as well, but I would recommend that you talk to your part suppliers about bonding quantities of these unique parts so that you don't experience delays in production due to supply issues. 20 weeks lead time is pretty expensive. So if you haven't heard all the buzz about this guy, it's the CC3200. It's supposed to be able to last for more than a year on 2 AA batteries. That's quite an amazing claim, but do take a look at the data sheet. You'll find that this kind of longevity is based on about a 20% duty cycle, and that's about a sample about every 10 minutes or so. And if that sounds like the IoT device that you're working on, then you should be fine. But in real life, most IoT devices are far more communicative than a blip or two every 10 minutes. I mean, you can imagine how problematic that would be for the smoke detector from sleeping most of the time. I would expect that this smoke detector would actually be awake most of the time. So anyways, back to managing the cost per node. If you take a close look at here, everything inside that gold square in the middle, that's your wireless solution. And there are 30-plus components there. If this is your reference implementation, the minimum number of components needed to get your IoT device talking with others and then with the Internet, this is where it starts. So as I mentioned earlier, manufacturers charge you per component to produce your IoT devices. So you have more parts means more expensive setups. More expensive setups can be mitigated by scaling up your orders, but only to a point. So if you can't manage all of this, your cost per node is going to start getting out of hand. So the key takeaway to this point is to get familiar, intimately familiar with the data sheet and the reference implementation of all of your primary and most expensive components, especially your wireless piece. Now, this wired or wireless as an option, they all have their place in the Internet of Things architecture. At some point, your devices need to be able to cruise the net. That's the purpose of it. But do all IoT devices need to be sitting fat on the Internet? The cost and complexity of deploying Wi-Fi or Ethernet connections everywhere, it's impractical. One way to reduce the overall cost of nodes and the crazy complexity and configuration and proliferation of points of failure is to use a single robust gateway, something that is capable of handling your HTTP communication, the payloads, and can also talk to a host of sensors, actuators, and whatnot around it. Functionally, the gateway reduces complexity without compromising on the primary objective of an Internet of Things thing. If you can imagine trying to support, and I say support, really it's babysitting billions of Internet-connected devices. Anything that can help reduce the madness in that equation is a feature worth shipping. So your gateway could be a Wi-Fi. That's the start. But having Wi-Fi on every component and have them all sitting on the Internet, that's what I'm talking about. The gateway helps you manage that aspect of complexity. So there is a golden nugget of wisdom in this article by TI, a paragraph or so down. They recommend at one point using non-IP protocols, which is an interesting idea, and also it's a logical progression in the idea of using wireless options other than 2.4 gigahertz, which is where using a module like ERIC makes for a clear path. This is a sub-gigahertz radio that has some amazing capability and fits TI's description really well, and it's inexpensive. Don't know if you noticed there in the bottom right-hand corner that I actually have a link to a reference implementation. It's open hardware. You're welcome to take advantage of that if you like. For me, this module, it's a no-brainer. Remember the $14 for just the Wi-Fi IC alone, and they add that to all the components that it takes to get that reference implementation up and running. You compare it to this, the comparison is very easy to see. ERIC is a system on chip. It's already complete, and you really only need a handful of components needed to get it up and running. So what you see here is actually about a $20 finished product, and it's representative of the cost per node. I know I said it, sub-gigahertz radios, which raises the question about which is better. You know, are higher frequencies better? Freese has something to say about this, and in a word, no. Simply, there are two major benefits from lower frequencies, and this is the primary benefit you see. Freese tells us that higher frequencies are more susceptible to interference, and that your signal range and coverage is reduced proportional to the amount of interference. So more 2.4 gigahertz devices in proximity equals more noise equals less coverage. You're just not going to get the distance out of the data sheets. You know, the data sheets list the distances that you're going to get, but with all that interference, you're not going to see those advertised distances. On the other hand, sub-gigahertz radios, they don't react to the interference the same way, and they're much more forgiving, which means that you're actually going to get those advertised distances much easier. So they're much less susceptible to the interference factor. In addition to this, there's the power requirements. Increased sensitivity translates more directly to efficient power usage. All the characteristics that we want going into those billions of devices out there, better power savings. It's worth mentioning that the radio module I just showed you a second or two ago, the ERIC module, it has some nice power management features as well. You should definitely take a look at the data sheet. So to recap this first section here, the important factors are to know what it costs to produce your reference implementation. You need to know the data sheet and what components are going to be required and what components actually require components so that you understand the total cost of what it would be per node. Because these are the things you're going to end up shipping to people. This is what they're going to be buying. And keeping that to a reasonable cost is very, very important. So obviously, you know, component counts can kill budgets. This is primarily in the setup aspects for producing your hardware. For every component that you put on the list means one of the components that they have to put onto a pick-and-place machine, which is a cost that you're going to have to absorb. The third item is that Wi-Fi is not your only option. There are a lot of options out there, and when it makes sense to use something else, then you should use it. But not to be thinking that in order to be able to make this an internet-connected device, that Wi-Fi is your only solution there. So the final item there is to get to know ERIC. It's an amazing SoC, and definitely recommend taking a look at that data sheet. Before I go on to the next section, I wanted to put a plug out there for anyone out there who might be listening to this presentation. If you're thinking that this is out of your reach, but you're interested in the IoT, and maybe you've got some ideas, but you're kind of struggling putting all the pieces together, there are people and services out there that understand this intimately and have actually created some really great services to be able to make these IoT devices of yours a reality. One of them is OSH Park. They will help you manufacture small quantities of your PC boards so that you can put together your prototypes. And it's very inexpensive. That module that I just showed you cost us about $6 for 3 copies of that PC board, so roughly $5 per square inch. And you're going to get those boards back in about 12 days. So order your parts from Farnell Element 14, order your PCBs from them, and by the time you get your order, you can put your IoT device together. Makes a lot of sense. If you've got more complex designs, they can also help you with multi-layer setups, and if it gets really complex, they can actually help you transit to full-scale production. They're very helpful guys. In addition to this, when you're dealing with some of these smaller components, people aren't as skilled with surface mount soldering, so naturally you have to start thinking about stencils. Well, there's also a service out there that can produce your stencils for you. It's very inexpensive and can help you get that IoT device shipping, something to consider. Okay, back into the presentation here. The features aspect of the Internet of Things. This is a difficult topic because I'm really referring here is the aspect of what features are available on all the parts that you might potentially be buying and what features that you actually need to deliver. And because of that, I'm going to use this topic called a minimum viable product to introduce this. And I'm going to do a bit of cherry picking here, but the spirit of the minimum viable product here is what I'm trying to deliver to you as an idea. To help illustrate this, I'll tell you the story that I heard when I first was introduced to this topic. There was a journalist, and he was talking to an entrepreneur about the idea of the minimum viable product. And the entrepreneur was telling him about it, and he introduced the idea of the world's greatest hot dog. And he asked the journalist, he said, well, what would it take to make the world's greatest hot dog? And the journalist responded with, you're going to need your mustard, your ketchup, and you're going to need buns, you're going to need your hot dog cart. And at one point, the entrepreneur stopped him and he said, but all those things aren't going to help you deliver the world's greatest hot dog. I mean, they seem very related, but really the core of your business, the core product, is the world's greatest hot dog. And all of those things other than that core piece are noise. They detract you from your business. They prevent you from being able to deliver that one central thing that you're trying to get at. So the important aspect of this minimum viable product is to focus on the things that are your core and to get rid of anything else that is not going to help you achieve that goal. Okay, so I did a little bit of cherry picking in the definition there, but we all know things that are over-engineered, they lack true usefulness. They just don't do any particular job well. I mean, here you have a combination of a fork, of a spoon, of a, but it doesn't do any of those particular jobs well. And that runs contrary to what the IoT is all about. Properly designed, an Internet of Things thing should get a job done and using the most effective path. Else, it's a waste of time, it's a waste of money, and it's a waste of resources. So taking this concept a bit further, I've seen a trend in the IoT and their projects that's a little concerning to me. Newcomers to the Internet of Things, be that experienced programmers, entrepreneurs, hackers, and the like, when they start to develop their projects and their ideas, they tend to gravitate towards platforms that are really powerful and that give them a lot of wiggle room. Platforms that they can program in relatively high-level languages like Java or C++ and Python. And all these platforms, they have a full TCP/IP stack. They have web servers and SMTP servers, FTP servers, and more, right? Now the Raspberry Pi is awesome. There are so many amazing projects on the net based on it. And now there is a new compute module which shrinks the tiny Pi down even further. This is not me saying that it's a bad thing. What I'm trying to say is if you need Linux and it's part of your core deliverable, then it makes total sense and you should deliver it with your product. If not, then you need to think about scaling it down. And this is a little bit of a personal definition here, but at the point of where you're dealing with an embedded device and you put Linux on it, in my opinion, you're no longer delivering an embedded device. It's now a full computer. So but just something to think about, but the reduction factor is very important. And what do I mean by reduction? I've heard the arguments a lot that these diminutive processors, they have so many limitations. It seems to take a lot of effort to be able to get things up and running. And and it makes a lot of sense in your early development to use a platform and processors and components that are loaded with features instead of these smaller devices. I mean, everyone loves features, But back to the idea of what the IoT is all about, doing a job, a single job really well. Any feature in a platform or a processor or a group of components that would comprise the core deliverable, that needs to stay on your bill of materials. Everything else, even though they might seem really cool or really desirable, they are a liability. They're a vector for attack, and they're a security risk. So the best way to deal with those aspects is to not deal with them and to try and whittle down your platform to just that core product. So we'll discuss that a little bit more in the next section, but suffice it to say that it's really important to hold true to the core concept of your IoT device and the minimum viable product. Okay, so if you had to make a list of the core features to include in your IoT project, this is one that should be at the top of your list. It's connectivity. You might have to read between the lines a little bit here, but there are 3 takeaways that I see. The first one is to select frequencies in the ISM band that serve the largest possible audience. Here I'm talking about 400, 900, and 2.4 gigahertz. That's 400 megahertz and 900 megahertz. And the reason here is he uses the term here to deploy globally. So that's where I get that first item from. The second item that I see in this is the plan for failure, or rather fail over. You need backup plans, fail-safe scenarios and such. No one wants to get locked out of their house when an access point goes on the fritz. The third item that I see in this, it has to deal with encryption. Connectivity without security, it's not acceptable anymore. There was a day when you could ship a product and you didn't have to worry about people tinkering with it. People just let these devices operate, and people weren't interested in how they worked. But there's this hacker movement. The people are very interested in how things work these days, and people are very interested in deconstructing these devices to the point where they discover what's going on in them. And in the process of doing that, they're discovering a lot of interesting things. And so if you can put that encryption aspect into it, it helps prevent some of that meddling with your device. I'll deal with that here in a section. The next section, we'll talk about that a little bit more. But back to the word about the radio spectrum and our connectivity. Use of the radio frequency bands and the electromagnetic spectrum, it's regulated by governments in most countries. And the spectrum management process, it's often referred to as frequency allocation or spectrum allocation. This is the spectrum allocation in the United States. And here is a comparative one for the UK. Radio propagation doesn't stop at borders. I mean, given the technical and economic reasons, governments realize that there's great value here in aligning these spectrums. So you're going to see some harmony between the spectrum allocations here. So this is true here that the ones that the spectrums that most people are very interested in then are the 400 megahertz, 900 megahertz, and the 2.4 gigahertz bands. And this is where certification via SEC or CE comes to place. Most component manufacturers already have done for you the heavy lifting in a wireless product and certified their wireless offerings with various agencies. As a matter of fact, the module I showed you earlier is a good example. They've done the heavy lifting for you, so that's a nice aspect to have. So now that we have all this sorted out as far as wireless options, frequency allocations, and whatnot, let's touch about what's actually going through that connectivity. And what I'm referring to here is it's data. We're sending data back and forth. And in the case where we've got some temperature sensor sitting on the network, we're sending 25 degrees Celsius. Now, if we think, hey, I'm going to send this over in XML, this is a bit of a joke, but it's a huge amount of payload here for a very little bit of data. In a day, you've got about, 1,400 or so minutes, and what you're seeing here is, 115 bytes worth of data. You're talking about 166K, which you might say, oh, that's not a big deal. It's nothing. But now if you think for just a second, if you hope to create the next big Internet of Things thing with hundreds or thousands or even millions or, like Gartner says, billions of devices out in the wild, that 166K is going to compound. And you need to think about what you're doing here because it could get you into a very bad spot. So you could say, well, I'll just use JSON and shave a little bit off of the overhead, which is good. This will actually save you a considerable amount. Or you could just go bare bones and minimal protocols are actually going to get you a lot more benefit there. So one thing to take from this part is connectivity is not free, and your only hope of protecting your bottom line with regard to that is keeping the data that you send focused. Now, we don't have to recreate the wheel. This is when it comes to getting IoT devices talking to each other and to Internet services. There are a lot of alternatives here, but this one is worth mentioning. Because it's relatively open with free server implementations to get you up and running, and free stuff is always nice. And it's the whole design behind MQTT kind of grows out of the grassroots efforts of machine-to-machine development, and it's useful for connections with remote locations and where small code footprints are required. This is something to think about. Give it a look. So what did we just go through for features? Think about the minimum viable product and how it impacts whatever it is you're working on. Pare your features down to the point of where you've got what that is. It's the world's greatest thing, and let everything else slide aside. It will help you in delivering your product. With regard to using Linux and whatnot, do what's right over what's easy. If you do it up front, you'll reap many rewards for doing that. And in the world of Internet of Things, connectivity is most important. With regard to frequency allocation, do think about those frequencies that are more available. And they might be, sub-GHz frequencies, but because they are global, it means that you will have to produce less parts, and that those parts are going to be more interoperable with a larger consumer base. Definitely something to consider. And then also minifying your data. Big features are great, big protocols are great for when they're needed, but if they're not, then simplify. And then do give MQTT a look. It's a great option. So now on to our third section here about security. Now, security it's a non-trivial component in the Internet of Things world, and should be designed in rather than bolted on. Authentication, authorization, access, and encryption should be given consideration early in the design process. As I mentioned before, historically this has not been the case. But with all of the data breaches and all the issues that have happened out there, I think that as a general populace, the world is becoming more aware that companies that are not making it a priority are actually a liability to them. And people are going to put their money in trust in the companies that they feel are serving them well. So it becomes mutually beneficial if the companies realize that and have that due diligence aspect. So years ago, on a high school trip to Arizona, we went for a visit to the Grand Canyon. This is a bit of a disclaimer, but I want to put this in perspective. That as I stood at the edge of that huge canyon, I just felt like that the gravity of this thing was pulling me in. It was just so amazing. And at that point that I looked at it, I realized, of what all that I was seeing, there were literally hundreds of miles more of this thing that I was seeing. It was just so expansive. Security is one of those topics. It's an expansive topic. And all we can do in just a few minutes that we have here today is talk about some very high-level things. Low-level details, those are subjects that you can do an entire another webinar on. So that's one of the things to consider here as I present the next few slides to you. Just consider this from a high-level perspective of developing an Internet of Things thing and what kind of security implications you might have. It's sad, but it's true. Small mistakes can add up. I don't know if anyone has seen this XKCD cartoon, but with the Heartbleed that had swept the world, and it was one of those things where people were just, it was a terrible thing. But the reality here is, the last frame there are some things that are safe, those things that are not digital. Moving on. First section, as far as security is concerned, there are some high-level things to cover. The reality of security, right? It's not absolute. And you've got to realize that it is a calculated thing, that you've got to protect your data, but there's also the cost going into it needs to be proportional. at any point your security is more tight than the data you're trying to prevent, you're actually causing yourself a little bit of hardship. So something to consider. Something else I've also heard in a lot of different reports is that people think that obscurity is helpful if you make it difficult to get to something. Well, obscurity is actually, it's not security. And we should make sure that we know that from the very, very beginning. And that obviously that in order to make something secure, then you have to have some trade-offs. And what about the trade-off? Well, I'm going to use some geometry here. And we'll talk about the security aspect. We'll talk about the functionality aspect of Internet of Things, and how easy they are to use. If we take this dot in the center as our product, and we gravitate more towards it's got to be more secure, naturally it's going to impact the other quadrants, functionality and ease of use. Similarly, if we say that this needs to be highly functional, then we may have to compromise somewhat on security and ease of use. Anytime you're doing this, you want to make sure that you're documenting these decisions so that if anyone asks you, you can at least defend why it is you made a particular decision. Then also, if you decide you want to make it very, very, very easy to use, then you might actually have to do something that will compromise functionality. So, moving on, where I'm going with all this is that regardless of how much you put into a particular piece of hardware or software, there are always going to be people that are creative, that do something that to compromise the system. Really, there is no countermeasure for determination, and you can only delay. So as far as security is concerned, what is good enough is do your due diligence, and then you can go ahead and continue on working on the rest of the features of your product. If you haven't seen this particular video, what happens here is this person has set up Legos to press the space bar and to click a button on a Kindle advancing the pages. The MacBook there takes a picture of the page, sends the page off to a service that does OCR recognition and turns it into text, essentially digitizing the book in a way to be able to circumvent the DRM. So people are very creative. And just keep that in mind. People are very creative. Also, this is another kind of it's another dig at having Linux on these embedded devices. If you need it, fine, but also realize that there's a security aspect that you need to ensure. For all the services that are running on any of these devices, the fact that they're discoverable is part of what they are. So making them not discoverable is actually going to prevent them from functioning correctly. So one of the concerns here is if you take Nmap, this is a free and open source utility to discover devices. Many systems and network administrators use this tool to be able to discover devices on the net. They use them for network inventory, managing service upgrades and schedules, pushing things to machines, monitoring host or service uptime. Nmap uses raw IP packets in novel ways to determine what hosts are available on a network and what services they're running. So even though this might be a good thing, it can be used for a bad thing. And if you haven't secured your platform, then all the parts that are not secured actually, again, will become an attack vector, which you don't have to have if you just remove them. So I'll give you some other ideas of security in Internet of Things. There's a guy, his name's Joe Grand, super intelligent guy, and he's recently had a very, very good presentation about some of the aspects of security that have been engineered into the hardware. And he's commented, though, that we need to get to a point of where we need to mature a little bit more. And as an example, he uses some of the techniques that he's developed in the last few years about removing epoxy and doing skiving and whatnot to be able to get down to the bare bones of the board and to be able to figure out what's going on as far as the hardware, to dump the ROMs and to take a look at what's on them. It's pretty amazing stuff. And from his talks, and this aligns with my opinion, and so this is my opinion and his kind of merged. But one of the ways to be able to make sure that your hardware is more secure is to remove things like a JTAG port from your board. If you don't need to deliver with that, then get it off your production hardware. I know that means more expense, but I just shared with you a way to be able to do inexpensive prototypes. And once you get to the point where your prototype's great, pull those parts and those traces off the board and then send your production boards off, and you should be good to go. Also, minimizing test points as much as possible. I know those are used to determine whether the boards are operational or not, but if you're concerned about security, then that's something to just kind of consider in the process. And the final item that he mentions is, when the hardware is out of your hands, it's out of your hands. Something to consider as far as total scope in delivering an IoT product. So, what can you bake in to your hardware and to your platform? Just managing expectations is a good thing. What does it do? What does it not do? And making a conscious decision of what direction you're headed. This whole idea of encryption, if the data that you're sending is important enough to send, someone else is going to be interested in it, and if you don't protect it, it is, again, a security issue. It's a potential attack vector. So encrypt. Just do it. Start with it, and you don't have to worry about it down the road. And this also has to deal with the hardware aspect of securing your platform. But then on the software side of things, like minimizing the attack vectors there, then listening ports, services that are running. If you don't have to have them running, make sure that you do some sort of an audit at least to make sure that the things that are not being used are removed from whatever system you're trying to deliver. And back to the hardware aspect of removing any traces or things from your device that you can, that actually can help. Some people, as they're developing hardware out there, they don't necessarily think about these kinds of things, and the costs can get expensive when you're trying to do this, but you have to balance that out. So the final comment here is that firmware. When you're talking about software in general, a lot of times people think that software is this dynamic living thing. But when you have an IoT product, you deliver it, and it's delivered, and most times you can't really update them. So you kind of need to come to some level of agreement with yourself on what happens with the firmware on a delivered product. If you're going to, open a channel to where you put a new piece of firmware on that is actually an open door now for anyone else to do the same thing. So something to consider, just as an aspect of the security that's a part of the Internet of Things thing, and as in the process of making a device smarter. So that was a lot of material, high level, very broad, and I'm sure you must have some questions. So I'll go ahead and open up the floor for questions.
All right, thank you very much, Rick. The first question that we've got is, 26 billion Internet-connected devices sounds like a lot. Do you really think that this is going to be possible?
Okay, 26 billion devices. That's a good point to make, that there are a lot of devices out there now even, probably much more than 26 billion. What I think that Gartner was trying to say by that is of all the devices we currently use, manufacturers are very interested now in putting the smarts into them. So I actually think that 26 billion is a pretty conservative number, but definitely at least that many. We're going to see devices becoming much smarter.
Okay, thank you. Next question we've got is, how does IoT, the Internet of Things, differ from M2M, machine to machine?
Oh, machine to machine versus IoT? Machine to machine didn't involve the whole network services aspect. This was primarily two devices talking directly with each other, not necessarily connecting to an internet service to be able to slurp up the data and then do something with it. So the Internet of Things, I would say, is an extension of the machine to machine market, and it adds in the internet services component to it as well, which gives additional capability to process the data, share the data, and make some additional smart decisions.
Okay, thank you for that. Just a reminder, if you have any questions, please put them into the Q&A window now. Are there any resources, we have another question, are there any resources that you can recommend for learning how to build IoT applications?
Oh, absolutely. There's actually one website that it's one of the best I would consider out there for learning about electronics in general and making smart things. The company is Adafruit, ADAFRUIT, and the website they have is learn, LEARN.adafruit.com, and they've got all kinds of amazing tutorials and guides on how to make things, the parts you need to make them, the code that would need to run on the microprocessors to get everything talking with each other, and they have a really great offering. So they have store items that you could purchase, or you can go to other suppliers, but a lot of the learning aspect there, I think, is really great material for you to start with.
Okay, we have a question from Martin Simlastic. He's asking if the slides will be made available. Martin, we're recording this, and the recording will be up on the website probably next week. Another question that we have is that of all the challenges facing IoT adoption, what do you consider to be the most important?
Yeah, that's a deep question. I would say of all of the issues that are facing IoT right now, the primary concern would be security. The reason I think that the security is the pinnacle issue is these devices expose people in a way that they don't realize to all kinds of malicious behavior. I was reading one article at one point, and a guy put a post in there about the whole thermostat issue, and his comment was, wow, this particular address, I can see that the TV hasn't been turned on in 2 weeks, and the thermostat is set at 82 degrees in the middle of August, which basically is an indicator that there's no one home, which would be great for thieves to be able to tie into that service. So there are unintentional attack vectors that are exposed in these ways that I don't think people have realized yet. So we're growing into this aspect of Internet of Things, and for any company out there that's producing projects and products that don't realize what kind of implications security has in this mix, they aren't willing to deal with it, they are going to run across these things. And it might be very bad for them, but I think that this is one of the things that could potentially stall Internet of Things is security. If there isn't a way to be able to handle this kind of stuff well, and I don't think at this point that anyone has a global answer, so yeah, that's a bit of a mix. But yeah, security, I would say, is probably the most important aspect to come to grips with if you're developing an Internet of Things project.
I have a question that follows on from that, is that, let's say for the sake of argument, we're not talking about necessarily hacking, but another development, which is big data mining. At what point does it become creepy and unpermissible in your view? For example, through having an Internet of Things enabled home, again, you can find out somebody's television viewing habits, how they set their thermostat, all sorts of individual preferences that a lot of companies, a lot of marketing firms would love to get their hands on. Where do you think the line is drawn? And do you think that this conversation as to what is permissible and what isn't, where do you think we are with that?
Yeah, that's part of what makes the it's part of what makes the Internet of Things amazing, but it's also what makes it, you use the word kind of creepy. And I think it has to come down to an education factor. The companies that are mining that data need to let you know that they're mining that data and allow you to be able to opt in rather than opt out. A lot of times you'll see services and things like that where they'll actually have very explicit terms of what they do with it, and they'll say, check here if you agree. It's not realistic, I think, at this point for everyone to read through a huge manual to understand what it is being collected about them. So there is some education aspect, I think, that would help. But simply the information that they're gathering, wow, because that's partially how some of these people monetize, some of the companies monetize their platform. In mining that data, they're able to sell that, and they can use that to reduce the price of the hardware and stuff like that. So it's a difficult question to be able to address in any one particular market. But I would have to say, to specifically answer your question, is they need to educate the people about what data they are collecting, and then give them the ability to be able to say, no, I would not like this information to be shared. And then if the data that's being collected is ever compromised, they need to have some plan in place to be able to scrub the personally identifiable fact from it, so that if it ever is compromised, the data is unintelligible to anyone else who doesn't have access to the connection points to that personally identifiable bit.
Okay, thank you for that. Next question is from Steve Anderson. He says, are long lead times, like you showed, a problem for most components or only a select few?
Things like resistors and capacitors and whatnot, lead times could bite you if a particular small part, if there's only one supplier for it. Like, for instance, highly precise resistors of like 0.01%, you might only get them from one company. that could be a bit of a problem. So that's something to think about, is saying, well, can we go to a different value where we've got 2 or 3 suppliers? So the first thing is to consider if how many suppliers you've got for a particular part. If you can maybe up the values of it so you can get more exposure there. And then as far as some of the bigger parts where, like we're talking about that wireless module at one point, I use the word bonding. If you go to them and you say, we've got a project, you can actually make sure that they understand that you require it, that particular part in your project, and they will reserve for you a certain amount so that you don't have to worry about getting it or not getting it. An amount of those processors or whatever that part are yours. You've paid for them. And so when they come off the line, they come directly to you. So speaking specifically to the frequency aspect, it really depends on what part you've selected, but you could experience long lead times with just about anything. And so the important aspect is to look out there to see who has what kind of quantities, and to try and make some reasonable decisions on, if you see, for instance, if you go on to Farnell element 14, you look at it and you see a particular resistor value, and they've got 20 million of them in stock. That's probably pretty safe to say that you can get that part any time. But if they're down into like below 1,000, and you're going to be producing your product in thousands, then that's probably going to be a bit of a problem, and I'd make sure that you could find that part from some other supplier. It's a difficult question, but the way to manage it is make sure that you've got primary parts lists, your bill of materials, you've got backups if you can, and any parts where you really don't have backups or no alternatives, bond those parts with the suppliers to make sure that the supply that you need is available.
Okay, thank you for that. Next question comes from Interoperability Singh. He's saying, if security is an issue, won't having a single IoT data aggregator or IoT firewall be worth standardizing?
Can you say that one more time?
He's saying, if security is an issue, won't having a single IoT data aggregator or IoT firewall be worth standardizing?
Actually, that's not a bad idea. If you base that around the MQTT protocol, then you could actually do some very nice work there. Speaking to an issue that emerged early on in this, there was a point when when Twitter education umbrella was out there, and you could post to Twitter from just about anything. It was amazing. People were tweeting, from a plant. That sounds like a great thing, but then Twitter looked at that and they said, wow, this is a big security problem. And so they shut that down, which meant that a lot of these devices that could normally communicate with those services were no longer able to. So, that aspect of an aggregator or a proxy or something like that can manage all of these kind of less intelligent devices but still capable of talking with each other to participate in the whole IoT mix, yes. I would say that would be a very interesting thing to explore.
I have another question related to interoperability. In my role, I've seen a lot of different platforms for building IoT applications. However, I'm a little bit concerned, based upon what I've seen, that these things might be siloed. Is that a genuine concern, or is that an obstacle to development of IoT applications?
Yeah, I would agree with that. I think that to some degree that these other people, services and whatnot, have siloed themselves, and they're doing that so that they can kind of control some of the quality, some of the responsibility. There's a lot of different reasons I'm sure that they do this for, and some of them they're doing it from a pure monetary point of view. They've created a great service, great opportunity, and they kind of close the doors except for the ones that they allow. And there are some benefits to that. But some of them, after releasing this, they realize, that this is really a really tightly closed ecosystem, and people want to have that freedom. They want to feel free when they're developing in the Internet of Things market. So sometimes they change their policies. A good example of this would be Electric Imp. When they first started, things were very restrictive. And they heard their audience, they listened to what they said, and they said, you know what? Well, let's open this up a little bit, and they did. And when they did that, a lot of people felt very good about that and started using their platform and investigating it as a solution even more. So I think that there's some benefit in kind of securing the platforms and reducing the footprints. But if it comes to the point of where the people who would potentially use it, they really can't use it well, then they need to think about the possibility of kind of expanding those gates a little bit. One of the hard points, though, is if you restrict, it's much more simple to raise the restrictions than it is to have something that's really super open and free and discover something that's a problem and you need to restrict at that point. With all the devices that are out there shipping, obviously you can't just update the firmware on 26 billion devices. Something like that would cause a very big problem. So I'm kind of caught between on that. Silos are bad, silos are good. I'm kind of in between. It would depend on the company and what they're offering, but I would recommend that those companies that do feel the need to do that are very careful with how they silo themselves.
Okay, thank you for that. Do we have any further questions from the audience? I'd just like to point out that you got a favorable comment from Don Berthke as well. He's saying, very good presentation. I like the idea of keeping the end product as simple as possible.
Oh, thank you. Thank you very much.
If we have no further questions, then I think we'll end the session here. Once again, thank you, Rick, for this fascinating presentation. Barry Beggs would also like to point out that it's a good webinar and he learned a lot from it. With that, I'd like to thank you once again, Rick, and thank Low Power Radio Solutions for making this webinar possible. Please stay tuned to Element 14 for more webinars on the Internet of Things and other fascinating topics. And with that, I'll say goodbye. Goodbye, everyone.